సరే అండి.
ఫెయిల్యూర్ అయిపోవడానికి మెయిన్ ఫార్మర్స్ అదే కాదు, మెయిన్ కాదు. ఎక్కడో బెంగళూరు నుండి రీచెస్ సెంటర్ పంపిస్తామని చెప్తాడు, ప్రైవేట్ ఇస్తాడు చీరలు. వచ్చిన తర్వాత ట్రాన్స్పోర్ట్లో ఏది వేసి పనికి పోయేసరికి అయిపోయేసరికి ఫార్మర్స్లో ట్రిప్ లాస్ అయిపోతుంది, మీకు చేయలేడు కదా. ఒకసారి ఒక బ్యాచ్ పెట్టమంటే ఒక 10-15 ఖర్చు అవుతుంది. ఒక ట్రిప్ లాస్ అయిపోయింది, రెండో తప్ప ముందుకు రాలేడు. అలాగే నేను కూడా ఫేస్ చేసి అది వచ్చేసి ఎడ్యుకేషన్ వెళ్ళాను, వర్క్ చేశాను యూనివర్సిటీలో చేసి స్కిల్ వచ్చిన తర్వాత
సార్ స్టార్ట్ చేయమంటారు సార్? Good morning to you all. Myself K. Venkanna, working as a lecturer in physics at Government Degree College Men's, Srikakulam. Today I want to deal with the two topics for second year students in thermodynamics and radiation physics. These two topics are disappearing filament optical pyrometer and angstrom pyr heliometer. Now I am asking one question to you. If you feel some feverish, what will you do? Generally, you will have some thermometer which will be kept contact with your body so that your body temperature may be measured by that thermometer. But these two devices, that is a disappearing filament optical pyrometer and angstrom pyr heliometer, these two are versatile devices. These two devices are non-contact devices. That means one can measure the temperature without any contact. Let us discuss in detail about these two devices. Now, my lecture will follow in a following stream, in a following these 5 guidelines. First of all, I want to discuss both the devices. I want to discuss operating principle, diagram, construction and working, advantages and disadvantages, and finally I want to discuss applications of both the devices. So first let me discuss about the disappearing filament optical pyrometer. Why it is got disappearing filament? Later, a little time later, you can realize why it is getting the name of disappearing filament optical pyrometer. First, let me discuss operating principle. The operating principle of this device is the optical pyrometer works based on the comparison of intensity of visual radiation emitted by the object. This is most important. Here we are measuring the visual radiation, not IR, not UV. We are measuring the visual radiation. Visual radiation ranging from 4000 angstrom units to 7000 angstrom units. So one more thing is the temperature of an object depends on two parameters. One is the color of the object, second one is the brightness of the object. So if you want to measure the temperature by seeing its color, we can say it is high temperature or low temperature.
వచ్చింది సార్. లేదు సార్ ఒకసారి కంటిన్యూ చేసాం సార్.
Let me discuss the advantage of our disappearing filament optical pyrometer. It is lightweight and portable. That means it is very handy. We can take from one place to another place very easily, and good accuracy compared to other radiation pyrometer. It can give good results from 700 centigrade to 3000 centigrade when compared to other radiation pyrometers. And this is most important one. No direct contact is required to measure the temperature of the object. That is why we are preferring these devices. And it can measure the wide range of temperatures ranging from 700 centigrade to 3000 centigrade. That is why we are calling it as a wide range. The measurement is independent of the distance between source and instrument. That is why we are not keeping in contact. We are measuring the temperature of the hot source by standing at some distance. These are the advantages. The disadvantages of the object are emissivity of an object affects the accuracy of the measurement. Here emissivity, we are taking emissivity from the filament lamp. That is, if it is acting like a black body, then we will get good result, accurate results. And emissivity of that radiation source also affects the accuracy of the measurement. And it may not be useful to measure temperatures below 700 centigrade. That I told you, because below 700 centigrade, if temperature of the source is below 700 centigrade, what happens? Then it will not emit the visual radiation. We have to compare the intensity of the filament and intensity of the radiation source in visual wavelengths. But if temperature of the source is below 700 centigrade, it will emit far IR radiations. That is why we are unable to measure or compare the radiations. That is the limitation, so that we cannot measure the temperatures below 700 centigrade. Similarly, we cannot measure temperatures above 3000 centigrade, because that is due to the filament. Tungsten filament will only withstand up to 3000 centigrade, because its melting temperature is near 3000 centigrade. That is why it can withstand up to there only. After that it will melt away. So that is why basically this instrument can measure temperatures ranging from 700 centigrade to 3000 centigrade only. And accuracy of this instrument depends on adjustment of equal brightness condition. Sometimes due to human errors, we may not adjust equal brightness condition. That means it is maybe filament may not be disappear, but we will treat that is the disappeared condition. So in that case you will get wrong values. That is why accuracy depends on the adjustment of the equal brightness condition. That is one of the disadvantages. Now let me discuss applications of this device. It can be used to measure temperature of furnace interiors and molten metal temperatures. Suppose if you go to the steel plant city, there the temperature of steel is around 1000 centigrade. But if you keep some thermometer, that also melts. So that is why we have to adopt indirect method or